Electrical Design Consideration for Tall Buildings, Part 04. 1. Lighting in high-end tall buildings. In high-end tall buildings, the design of the lighting treatment is usually undertaken by a lighting design specialist who will develop a design that enhances the architectural features of the building. The electrical engineer must work closely with this designer when developing the power and control systems for the lighting. Frequently, the electrical engineer is responsible for coordinating with the other design professionals with respect to the lighting design. For example, the structural engineer may be required to ensure that the structure can adequately support large chandeliers, and the mechanical engineer must ensure that the cooling system accounts for the heat generated by the lighting. 2. Aircraft warning lights. Aircraft warning lights are an essential requirement on any tall building. In the United States, these systems must comply with Federal Aviation Administration requirements. In much of the rest of the world, the ICAO standards apply. The red, sometimes white, warning beacons are located at the top of the building and at intermediate levels as dictated by the standards. By their nature, these beacons are conspicuous, which often conflicts with the architect's vision for the building. The architect and engineer must work together to locate these lights so that they fulfill their intended purpose and limit the impact on the aesthetics of the building. 3. Lightning protection. Inevitably, extra-tall buildings are occasionally struck by lightning. To protect life and property, it is important to provide a well-designed lightning protection system that complies with the local standards. Once again, the electrical engineer must cooperate closely with the architect and structural engineer. The lightning protection system will form a Faraday cage around the building. The architect and engineer must work together to ensure that the copper grid placed at roof level is adequately secured. The electrical engineer must work with the structural engineer to locate the down conductors that direct the lightning energy to the earth. Copper conductors within the structure can be used, however this added cost is unnecessary since the rebar that exists within the building columns already is also a good conductor and is commonly used for this purpose. 4. Extra low voltage systems. The electrical engineer is responsible for the design of extra-low voltage (ELV) systems. The ELV systems may include the fire detection and alarm system, voice evacuation system, voice and data communication systems, public address systems, access control systems, intrusion detection systems, CCTV systems, audiovisual systems, cell phone and wireless distribution systems, and other such auxiliary systems. Increasingly, because ELV systems are converging and systems communication takes place at a high level, the electrical engineer must ensure that the various ELV systems are coordinated and are able to communicate flawlessly with each other, as required. The electrical engineer must have a clear understanding of how each system operates and how they are to interact and support each other. Today's ELV systems are continuously evolving and being upgraded rapidly, so that the system that the electrical engineer selects during the design of the building may be outdated before installation. The electrical engineer's design must be flexible enough to limit changes to the physical infrastructure when the ELV systems are updated.